Okay, so on to the final one of our design principles now, so the D in solid, and this stands for Dependency Inversion Principle. So the idea here, if you imagine an application is made up of many layers, you may have a bunch of low-level classes, and a bunch of classes at a slightly higher level that use these low-level classes. And the idea is rather than having your high-level classes just use the low-level classes directly, be tightly coupled to those classes, is to introduce a level of abstraction, so that the high-level classes depend on those abstractions, rather than the concrete implementations themselves. This makes it much more flexible, so if you need to replace those low-level classes with a different implementation, you're then free to do so. So the way you would typically do this is by introducing interfaces into your system, so the high-level classes would just use the interface, rather than the implementation to the interfaces directly. Another important point is the abstractions shouldn't be depending on the details, i.e. the low-level classes. So the interfaces themselves must talk in terms of those abstractions, in terms of those interfaces, not in terms of the concrete implementation classes. Now this is important not just for creating maintainable code and enforcing good design practice, but especially so when using a test-driven approach, as we really do need those abstractions, because those are what we'll be replacing with test implementations later on, as we'll see. Okay, so looking at an example now, let's imagine with our shapes example we want to be able to store our shapes on disk somehow. So for our circle class we might have a circle serializer that knows how to write a circle's information to a file. Now we could couple our circle serializer to the file class directly, like this, but it's not very flexible. It makes it very hard to change how the circle serializer behaves if we wanted to change it to serialize to a different resource rather than a disk-based one. Maybe it could be to some database or data store somewhere. This would be pretty difficult with the way it stands currently. So what we would do is we would introduce an interface, in this case a data sync interface. So the circle serializer talks to our interface and our file class implements this interface, thus giving us the decoupling that we need. And because we're talking about an inversion dependency here, the library that contains the file implementation class would not typically contain the datasync interface itself as well. This would typically be defined elsewhere, so that both the high-level code, in our case the serializer, and the low-level code, the implementation, the file class, both of these would depend on that same abstraction, that same datasync interface. This decoupling makes our system more flexible, easier to change, and when it comes to testing it, particularly with TDD, it's going to make it a lot easier to test. We don't have to deal in terms of real files, we can just use a test implementation of our datasync interface. It's very common to see with a system that has been developed with a lot of tests, and especially one that's been developed using test-driven development, it's very common to see a lot of interfaces in the system. And this isn't a bad thing. If anything, it forces you to think about the responsibilities of those interfaces and really reinforces the other principles that we've talked about.